You know that feeling when you're trying to pat your head and rub your stomach at the same time, and your brain just sort of reboots? It's embarrassing. Humans like to think we're the peak of evolution because we have these massive centralized processors sitting in our skulls. But if you really want to see a masterpiece of multitasking, you have to look under the waves at the octopus. These guys don't just have a brain, they have a decentralized government. While you're struggling to walk and text, an octopus is managing 8 different limbs that essentially have their own personalities, their own memories, and, most importantly, their own brains. We are talking about a creature that literally thinks with its feet. If you've ever felt like your left hand doesn't know what your right hand is doing, just imagine being an octopus. They don't just have a split personality, they have a split anatomy. Today, we're diving into the strange, squishy, and terrifyingly brilliant world of cephalopod intelligence to figure out how having brains in your tentacles actually works, and why it makes them the ultimate escape artists of the ocean. To understand how wild this is, we have to look at the hardware. A typical octopus has about 500 million neurons. For context, that's roughly the same as a dog. But here's the kicker. Only about a third of those neurons are actually in the central brain. The other 2/3 are bundled into clusters called ganglia, located inside the arms. Imagine if your biceps could decide to pick up a sandwich without asking your head first. That is the daily reality for an octopus. This anatomy creates a bottom-up intelligence. The central brain is more like a CEO who sets a general strategy, say, hey, I'm hungry, let's go find a crab, while the arms are the middle managers who actually execute the plan. Each arm can taste, touch, and move independently. If you cut off an octopus arm, which please don't, that arm will actually continue to react to stimuli, grasp at food, and even try to bring that food to where the mouth used to be for quite some time. It's not just a reflex, it's localized intelligence. Why would nature design a creature this way? Think about the logistics of having 8 highly flexible, boneless limbs. If the central brain had to calculate every single micro-movement of every suckered appendage, it would probably overheat and explode. By outsourcing the processing power to the arms themselves, the octopus avoids a massive neurological bottleneck. This allows them to do things that would make a human gymnast weep. One arm can be busy prying open a stubborn clam, another can be checking a nearby crevice for predators, and a third can be changing the skin's color and texture to blend into a rock, all while the central brain is focused on navigating the current. Let's look at some examples of this distributed genius in action. Researchers have watched octopuses solve complex puzzles, like unscrewing jars to get to a shrimp inside. This requires a level of hand-eye coordination that is frankly insulting to those of us who still struggle with child-proof medicine caps. Because the arms have their own mini brains, they can explore a jagged coral reef with incredible efficiency. One arm can feel around a corner and identify a texture as prey based on chemical sensors, literally tasting with its skin, and initiate a strike before the main brain even realizes lunch has been served. There's also the famous mimic octopus. This is the ultimate theater kid of the ocean. It doesn't just camouflage, it impersonates. It can pull its arms together to look like a sea snake, or spread them out and flatten its body to look like a toxic flatfish. This level of physical manipulation requires an insane amount of localized control. The arms have to know where they are in space and what shape they are forming without the main brain constantly checking a mirror. Then there's the sheer mischief. At the University of Otago in New Zealand, an octopus famously figured out that the bright lights in its tank were annoying. It learned that if it squirted a jet of water at the light bulbs, it could short-circuit the power and turn them off. It did this so often that the researchers eventually had to release it back into the wild. That wasn't just a reflex. That was a creature using its distributed nervous system to observe, learn, and then engage in a bit of electrical sabotage. Think about the implications of that for a second. If an octopus can learn to manipulate its environment using tools, or even just using its own specialized water jets, what does that say about the nature of intelligence? We usually define smarts by how well a brain can process abstract thoughts, but for an octopus, intelligence is physical. It's baked into the very fabric of their limbs. They can solve mazes, remember faces, and even show signs of playfulness. Some captive octopuses have been known to play with toys like floating bottles, pushing them back and forth in their tank currents for no reason other than apparently because it's fun. It's hard not to feel a bit of kinship with a creature that gets bored and starts messing with the staff. But the hardware differences go even deeper. octopuses can actually edit their own RNA. While we're stuck with the DNA we were born with, octopuses can tweak their genetic instructions on the fly to adapt to temperature changes in the water. This is like being able to rewrite your own operating system because the room got a little chilly. Combined with their decentralized brains, this makes them one of the most adaptable and resilient organisms on the planet. They are essentially alien intelligences living right here on Earth, reminding us that there is more than one way to build a mind. We think of ourselves as the masters of the planet because we built skyscrapers, but octopuses have survived for nearly 300 million years without needing a single brick or a centralized neural network. They are the ultimate proof that you don't need to follow the human blueprint to be a genius. In conclusion, we need to stop using the term bird brain as an insult and maybe start using human brain to describe someone who can't do two things at once. The octopus proves that you don't need one big ego in a skull to be a genius. Sometimes having 9 brains, 1 for the big picture and 8 for the dirty work, is the most efficient way to navigate a complicated world. They are the ocean's most brilliant multitaskers, masters of disguise, and occasional electrical engineers. They challenge every assumption we have about how brains are supposed to work and remind us that evolution has some pretty wild tricks up its sleeve. Next time you see a picture of an octopus, don't just see a squishy sea creature. See a decentralized supercomputer with a sense of humor and a very specific grudge against light bulbs. It's a strange, wonderful world down there, and the octopus is definitely the one holding the remote. Thanks for watching. Subscribe for more videos.